Hello everyone. Today we are going to see the namespaces in C++. So it is going to be a big video. So for that, we have divided the video in two parts. So in the first part, we'll be talking about the usage and the ambiguity and how to access the namespaces. So let us start. So namespace in C++ is a declarative region that provides a scope to identifiers. So you can think of it as a container, and that container we can use it to define variables, functions, classes, enums, and etc. It is mainly used to avoid collision between different part of large programs or between the code and the third-party library. So what it actually means is that your C++ code allows you to break it down into multiple files, libraries, and modules. So if you're working in an industry code, so the code might be very large, or the code base can be very vast, so that if you're creating any new classes or functions, your name that you are thinking of, they might get collided with some name which are already being used. So in that case, you can have a collision. To avoid that, we can use the namespace. Let us take an example of a logger class and try to see how the namespaces can help us in this case. So I'll create a file, say test1.cpp. Now in test1.cpp, first of all, let us say we are working on a code where we work on system code, plus we also work on network code. So I have been assigned a task to design a logger file or a logger class where I can use that class to log out some data in case of network and core system, both of them. But the class should be separate from each other. So include iostream using namespace std. Now what I can do is, let us say I have a class logger, and inside the logger class, I have some function called void log, which takes constant string reference of message, right? So I chose this logger class to be the class for my core system logs, say system logger class. Now I also want to design a logger class for my network logger class, and they should be different. Class logger. In the public section, I would be having a function called log, but this time let us say it only takes a code, which is the network code, as an argument. Now, if I'll try to compile it now, then obviously it will give me error. Why? Because we have two classes with the same name. So we are redefining the same class. Let us put int main and let us keep it empty for now. Right. So G++ test1.cpp dash o, say test1. So you can see we got an error, which is the redefinition of class logger, right? So how can I resolve this issue? We can resolve it using the namespace. Now, say for system, we have something called namespace core. And I'll just wrap around the class inside the core namespace. Let us also correct the indentation. And in the same way, for network, I'll have the namespace network, and I'll wrap the complete class around. Now, if I'll try to compile it, After wrapping both the classes into separate namespace, you can see it compiles successfully. We don't get any redefinition errors. So you can see that the logger of the core and the same logger class of the network both coexist in the same file safely. So that is one of the most important advantages of using the namespace, right? It avoids the naming collisions. Now, to access the data which is inside the namespace, there can be two ways to access the data. So I've also created nodes. So you can go through the nodes. In the nodes, I have written everything separately. So there are two ways through which we can access the data. One is using namespace, and second is using the specific identifier. Right. Let us see in the code itself. So say we have a function. Let us create another function. Say we have void greet, and the greet method says cout hello world. And right now, if I want to access this greet method, what can I do? The first thing that I can do is using namespace core, and I can straight away call the greet function. Since I've written using namespace core, it means we are going to use everything which is there inside the namespace is going to be loaded inside the test1.cpp, and then we can use the greet method which is there inside the core directly without specifying anything. So if I'll try to compile it, it compiles successfully. Now if I'll try to run it, okay, if I'll try to run it, test1 test1.exe, so it prints the log successfully. So this is the first way of using the namespace. The second is you can specify the specific identifier that you want to load. So you can say using namespace core, and inside that you can specify I want greet, right? So in this way also you can say, okay, namespace will not be there. Using inside core, you want greet to be there. And now you can directly call the greet. This will also work. So if I'll try to compile it now, it compiles successfully, and if we execute it, it executes the same output. Now, I could have also done, instead of this, I could have gone for straight away core and specifying the greet method using the scope resolution. Now, if I try to compile it, it still does the same. So, this way you would have understood what are the ways you can use the namespace. Along with this, there is one more thing, which is anonymous namespace. Right now, we are using the name of the namespace, but there it is possible that you can create namespaces without the name. So in that case, let us create a namespace, and without any name, it is actually called anonymous namespaces. Anonymous namespace. Now, anonymous namespace can also have any method or variables you can define inside. So let us create some hidden value, which is 100, right? So let us also create a function, say void internal function, and inside the internal function, let us say we have anonymous namespace, right? So since it is an anonymous namespace, what it does is everything which is defined inside that namespace is going to be visible to the class or the current translation unit. So everything which is defined inside can be directly accessed inside the test1.cpp. So you can say that it is equivalent to defining it as a static in global scope. So the hidden value as well as the internal func will act as static function and variable. So if I would call it internal func straight away inside the main method, it will work absolutely fine. So the point here is that if we have an anonymous namespace, anything which is defined inside will act as a static variable or function, and it will be visible inside the current translation unit or current file. Now, if let us say there is another file, say test2.cpp, which also has another anonymous namespace, and it also has the hidden value hindered in internal func with the same name and same signature. So in that case, since we saw that it is going to act as a static uh, variable and method, so in the same way, they will be treated as different even if they have the same name, but they are scoped to the same to the current file only. Now the namespace can also be nested. So let us take another example. Let us try to create another file. So test2.cpp. Now inside this, let us start with the namespace only. So namespace company. Let us say we have a company namespace, and inside the company namespace, I have a project namespace. Say namespace project, right? Now in the project namespace, let us say we have a function called void run. So I can declare it right now, and I can also define it at later point. Say if I just declared it at this time, and I want to say, if I want to define it, I can say namespace company project, and inside this I can have void run, and we can say cout running project, right? So for this, let us include the libraries hash include iostream and using namespace std. So in this way you can define the methods inside the namespace as well. Now if you want to call this run method, say int main, so you could have called like company. Inside that we'll call project, and then inside that we have the run method, so we can call it this way, right? Return 0. So you can see that the nesting of the namespace is also possible. Namespace, but you might be thinking that this nesting can go a long way, and in that case how is it possible to access those methods, that we always have to write down the complete path for it? It can create ambiguity. So it is also possible for you to have alias for the path or shorten the path for the namespace. How you can do it is, say, you can straight away say namespace, say cp equals to company. Inside that we have the project. Now with this, we can directly call cp and run. So if I try to compile it now, it still compiles successfully. And if we try to, okay, we have to run test2. So let us name it test2 over here. It compiles successfully. And if I would run it, then it also runs perfectly fine. So this is the way you can use the aliases. Namespace. Now we can also use inline keyword with namespace. So I've created a separate video completely on inline, but in case of namespace, it works slightly different. So we'll cover that part in this video. So if you put inline with the namespace, then what it does is it takes the visibility of all the variables in the methods which are scoped inside the current namespace and makes it visible to the parent scope. So let us take an example and try to understand it. So let us say we have a namespace, say API, and inside this, I create a namespace v1, and we have, say, a function called void process, which see out version 1. And then we have another namespace v2 void process, and again we are going to see out version 2. So now if I want to call the versions, let us comment this out. If I would like to call the process method of any of the versions in the API, so I can call like API v1, and inside v1 I can call the process, right? In the same way, API v2, and then I can call the process method. So if we'll compile it, it compiles successfully. If we try to execute it, we can see both the versions are getting printed. Now, if I'll put a inline keyword before the namespace v1, what will happen is that everything which is there inside the v1 namespace will be visible in the parent scope. So the parent scope is API, so it will be visible in the API namespace. So since I've written the inline keyword before v1 namespace, so we can now call API and then process. So this process is actually inside the v1, but since we have made it inline, so it is visible to the parent scope. So if I'll save it and if I'll call it, let us compile it first. And if we'll execute it, you can see v1 getting version 1 getting printed twice. Now, in the same way, if you are going to make the parent namespace inline, in that case, you are just going to make everything inside the API visible in the global scope. So now you can call the process, since both the classes are in, both the namespaces are inline inside it. So you can straight away call the process without using any scope resolution. So you can directly call process. But if you want to access the process of v2, then even now you have to access it using a v2 and now the process. So if I'll compile it now, you can see there are no errors. If we print the versions, so you can see 3 times it is printed version 1 and twice version 2. So hope you have understood how inline works with this. But the point here is, why do we need this inline keyword? If I would just use the inline keyword with the topmost parent namespace, then it is just going to make everything visible to the global scope. So is it useful? No, it is not. So mostly it is not used for making the top namespace inline. If we are doing this, then we are actually polluting the global scope. So we should avoid doing this. But the inline keyword is majorly used when you are using any of the nested namespaces as inline. So in that case, what it does is, say if you're having some kind of library and you can make versioning, like this is the version 1 and this is the version 2, and you want to make default process of version 1 to be visible uh, throughout the API. Whereas if someone wants to access V2 version, then they can directly access it using the scope resolution. So in that case, inline keyword is can be used with the namespace. So that is one of the uh, points where you can use it. So it is like not a good practice to use the inline keyword at the topmost namespace. Now let us see one more thing, that the namespaces can be opened and they can be closed at any point in the code. So the namespace do not have to be defined at a single place in the code. So let us see this thing with an example. I'll just create another file. First of all, we'll create a header file, tool.h, or let us say tools.h. And inside this tools.h, I'll create a namespace, tools, and I'll just declare some of the functions, say void helper1, and we have void helper2, right? So we have just declared two functions which will be there in the tools. Now I would create a file which is, say, tools test1.cpp, and inside tools test1.cpp we have to include the header files iostream and hash include tools.h. iostream because we are going to define the helper methods. So I would say namespace tools, and the namespace tools is going to have the method the helper1 which we have declared. I'll define it at this point. So we are just going to log out something helper1 called handle. So we can mark it as using namespace std. Right. Now let us also create another file which is tools test2.cpp. Now inside this, I'm going to do the same, include iostream hash include tools.h using namespace std, and now the namespace tools. But this time I'm going to define void helper2 cout helper2 called. Now let us create a main file. So we have main.cpp, and inside the main.cpp, I'm just going to say include and tools.h will be having int main method, and inside int main, I can call tools scope resolution helper1 and tools scope resolution helper2 return 0. Now let us try to compile this code and see if it works. So we have G++, tools test1, and we have tools test2, and then we have main. Let us name it main only. So it compiled successfully. If I'll try to execute it, main.exe, so you can see helper1 is called, helper2 is also called. So with this example, I was just showing you that since we have declared two methods inside the tools, and if I'm going to define it at two different translation unit, even if my helper1 was defined in tools test1.cpp and in tools test2.cpp, we have defined helper2 method. So even then it works absolutely fine. Why? Because the namespaces can be opened at multiple places and we can work with them at different points as well. Now, let us also see an ambiguity while using the namespace. So I'll just create another file, ambiguity.cpp. Inside this, let us say we have a namespace A, and inside namespace we have a print method. We'll keep it simple. So let us say std cout, and we just print the class name A, std end, right? Let us have include iostring. Now we have in the same way namespace B, and namespace B is also going to have a print method, and we are going to say std cout, and this time the class name B, std end. Now, if I'm in the main method, if I'll just write down that call the print method, and before calling the main method, I'll say that using namespace A, and in the same way, I'll also write down using namespace B. Then it is actually going to give me an error. So the point here is that the compiler is not able to identify which function to call, because we have both the functions and we are using both the namespaces, so the compiler will not be able to identify which print method has to be called because they have the same signature. So this is the ambiguity while using the namespace, so you should be careful about using this. So if I'll just comment one of them out, the error will be gone, and the compiler will be able to identify, because the corresponding print method will be taken into the ambiguity.cpp file. So this is the reason why many of the places you would see people are not uh, using namespace std. Why? Because like first of all, when we write down using namespace std, it will bring up everything which is there inside the std into this translation unit. So we don't want that. We only want those things to be taken which are actually needed. Like we only need the cout and endl, which are used from the std namespace. So uh, we are only trying to access these two. Rest, we don't want anything else. So I would suggest, like if you're just coding for a small piece of code, you can write down the using namespace std for practicing on lead code or somewhere. You can use the namespace using namespace std. But in case you're working on a large code base, in those areas you should avoid writing this down, and you should straight away go for std scope resolution. This is like a good practice to code. So this is the end of part one. The next part will be there. We will be covering the argument dependent lookup and how it is used with the namespace. So if you have any doubts, you can ask in the comment section.